Good morning, everyone. Today we are going to deal with the chapter Haloalkanes and Haloarenes from Chemistry Part 2 textbook. This lecture aims for NEET, JEE, CBSE board examinations, CET examinations, state board examinations, ICSE examination. ICSE not preferable, but for CBSE and CET examinations and JEE mains, NEET, etc. Preferred lecture. So we will be dealing with the textbook order. So first, this is the chapters NCERT is here. Haloalkane, Haloarene, 6th chapter, Haloalkane, Haloarene. So there are a lot of things written in this first paragraph. Always don't forget to read these first paragraphs. They may ask some direct questions from this paragraph. So the replacement of hydrogen atom in an aliphatic or aromatic hydrocarbon by halogen atom result in the formation of alkane halide, haloalkane, arene halide, haloarene respectively. Haloalkane contains halogen atoms attached to the sp3 hybridized carbon atom of an alkyl group, whereas haloarenes contain halogen atom attached to the sp2 hybridized carbon of an aryl group. Many halogen containing organic compounds occur in the nature, and some are these in clinically useful. These classes of compounds find wide application in industry as well as in day-to-day life. They are used as solvent for relatively non-polar compounds and as starting material for the synthesis of a wide range of organic compounds. Chlorine containing antibiotic. So which is the chlorine containing antibiotic told in this lesson? Chloramphenicol. Very important note. This should be noted because this can be asked. Okay. Produced by microorganisms, very effective for the treatment of typhoid fever. Our body produces iodine containing hormone thyroxine. Which is iodine containing hormone? Thyroxine. And the deficiency of which causes a disease called goiter. Goiter is the disease caused by deficiency of thyroxine. Thyroxine is containing what? Iodine. Synthetic halogen compound like chloroquine is used for treatment of malaria. Which is used for treatment of malaria? Chloroquine. Malaria. Halothane is used for treatment of halothane is used as an anesthetic. Very important. Underline these things. Certain fully fluorinated compounds are being considered potential blood substituents in surgery. In this unit, you will study important methods of preparation, physical and chemical properties, and use of organohalogen compounds. So, first of all, in this chapter, we are dealing with what? We are dealing with classifications. We are classifying the haloalkanes and haloarenes. Okay, haloalkanes and haloarenes can be classified. So there are many types of classifications on the basis of, first we are going to tell on the basis of number of halogen atoms attached. How many halogens are attached? So if one halogen is attached to a carbon, this is called what? Monohalogen. Monohaloalkane. Mono. If two, in the compound, if there are totally two halogen atoms somewhere attached, it can be the same carbon, it can be the different carbon, like this. It can be like this, or it can also be like this too. Like this also. This is also a dihaloalkane. But the problem is that these two have a separate different names for the orientation, because here the X is in different carbon and here the the halogen is in the same carbon. So we'll call them visceral and geminal. That is being dealt in the lesson afterwards. I think somewhere here is written detail. So there we'll be dealing with that thing. But now I'm just telling there are two halogen atom. It is dihaloalkane. Next, if there are three halogen atoms, can be like this also, no problem, CHCl3. It's called a trihaloalkane. Now it's the same thing. If it's a benzene group, that arene group, then it's a haloarene, dihaloarene and trihaloarene. That's what told here. Now compounds containing sp3-CX bond. This class include alkyl halides or haloalkanes. The halogen atom is bonded to an alkyl group and they form nothing. Alkyl halides or haloalkanes. Look here. If all are single bonds, like it's like this. If I am considering this thing, this is called a what? It's called a alkyl halide. Okay, this is called a alkyl halide. Alkyl halide. So there is a question from my side. So what this compound is? It this compound a alkyl halide? Is this a alkyl halide? No, this is not a alkyl halide. Because double bond is here. It can't be alkyl halide. If double bond is attached to the carbon which is attached to X, if X is attached to a double bonded carbon or sp2 hybridized carbon, it's not called a what? An alkyl halide. It's not called a alkyl halide. Now, is this alkyl halide? This is called alkyl halide. Is this one second? Is this called alkyl halide? No. This thing is called a allylic halide. If the halogen atom is attached to a carbon which is attached to an sp2 hybridized carbon. If this chlorine is attached to a carbon which is attached to an sp2 hybridized carbon or doubly bonded carbon, then we call them an allylic halide. That's told here. Okay, this example, look, double bond. Then next carbon. This carbon is attached to this sp2 hybridized carbon. X is attached to it. It's an allylic halide. And this carbon we call it what? An allylic. It's written here. An allylic carbon. Here also this carbon is the allylic carbon, and what attached to that allylic carbon is called what? This is an allylic halide. Then you can ask me something. Look. Then what about, one second, sorry. Yes. So this is our benzene. Okay. So why does benzene look like? This is a benzene. So you can ask that. Here there is a CH2. So this is also like, look, this is also like C is here. This is an sp2 hybridized carbon. C is directly attached to it. So this is a chlorine. So everyone will write this as an allylic halide. But this is not called an allylic halide. This is called a benzylic halide. Why? Because here this carbon, we call this carbon what? Benzylic carbon. We call this as a what? A benzylic carbon. So if a chlorine or if a halogen atom is attached to the benzylic what? Carbon. Benzylic carbon, then it is called a benzylic halide. Now that's over. Now we are coming to compounds containing sp2-CX bond. Very important. Here we discussed about compounds containing sp3-CX bonds, right? sp3-CX bonds, because here look, allylic halide also have sp2. Benzylic also have that. Let it be there. Okay. Sorry. Now vinylic halide. Nothing. If a halogen atom is attached directly to an sp2 hybridized carbon, example, this thing, it's attached directly to an sp2 hybridized carbon. This is called what? A vinylic carbon. And if it was a benzene ring, here also the double bond is there. So many people will think we can call this also as what? A benzylic. What? This is thing. This is also like directly attached to sp2 carbon, so we'll call this also vinylic. No, but if it's a benzene ring, we call it as aryl halides or haloarenes. Okay, yes. That's about it. That's about our classifications. Now we directly come to nomenclature. Nomenclature is very simple. You can just go through nomenclature because it's not that important. They don't. You can just refer the old chapter we learned, which is that chapter. Yes, the basics of organic chemistry. The first organic chemistry chapter of your class 11. In that, everything of IUPAC naming is written detailed. So that's enough, I think. But there is one thing I have to tell you, and that is this. This thing is what I have to deal here. Look here. If I told you about, if there are two halogen atoms in a compound, then it's called a dihalogen compound. If in a dihalogen compound, there are possibility that both the chlorine atom can be attached to one carbon, or it can be attached to what? Different carbon. It can be attached to different carbon. These two are possible, right? So the formula is for our C2H345 H5Cl2 for both compounds, but the arrangement is different. If it has this arrangement, we call them, IUPAC name them as 1,1-dichloroethane. 1,1-dichloroethane. Okay. If it is this thing, we'll name it as 1,2-dichloroethane. That's okay, we know. But commonly, if two halogen atoms are attached to the same carbon, we call them geminal dihalide. And if it is attached to different carbon, we call them vicinal dihalide. So that's the thing which is important here. So if both are attached to same carbon, it is what? Geminal dihalide. And if both are attached to different carbon, it is what? Vicinal dihalide. No, geminal. Geminal what means? Gem. If both the carbon are with both the halogen atoms are with one carbon, it's a geminal dihalide. And if two chlorine atoms are with different carbons, then it is vice. Then it's called what? Vicinal dihalide. But this what codes to remember and all are really useless. It's better to by heart. That's the better thing to do. Codes and all for by hearting is good for what? D and F block coordination compound and all, not for this chapter. Just learn it. Only this thing I have to tell in nomenclature, which is important. All other things are very simple. And this naming and all is very simple. Okay, not a matter. Now we come to our chapter, really into our chapter, and we will be first dealing with the nature of carbon halogen bond in the what? Haloalkane. You know that halogens are very electronegative, and carbon is what? Somewhat we usually include carbon as an electropositive element. Pakshe means you know that what? Halogen is the most what? Electronegative atom exists in the universe. Most electronegative atom. So halogen, for any way, it will pull the electron shared in the covalent bonds towards itself, gaining it a negative charge. Not total negative, a partial negative charge. If a halogen gets a partial negative charge, for sure carbon will get a partial positive charge. So they are telling that the bond in a haloalkane is what? Polar in nature. Okay, that's the thing. As we go down, this thing you can read, as we go down in the group period, the size of the halogen atom increase. Fluorine atom is the smallest, hydrogen atom is the largest. Consequently, the carbon halogen bond length also increases from C to F. So typical bond length, bond enthalpy and dipole moments are given in the table 6.2. Just look here. Look here in this table. CH3F bond length order. This order is very important for bond length. Bond length always will increase down a group. So bond length order is like this, increasing down a group. So if bond length increases, bond enthalpy, what happens? It will decrease. It will decrease down a group. So here it is increasing down a group. Here it is increasing up a group. Increase. It's increasing up a group. So if a bond length is you have learned it. Bond length is inversely proportional to bond enthalpy in chemical bonding class 1, class 11. You may have learned the same. So that is telling that if bond length is greater, then bond enthalpy is less. If bond length, if two atoms are very much apart from each other, like two atoms are far away from each other, then what we can tell? We can tell that it is very easy, it is very simple to break the bond, right? It's very simple to break the bond. That's what we can tell. Now dipole moment, please look. Dipole moment increases up a group because electronegativity decreases down a group. The most electronegative is fluorine, therefore dipole moment will be more for CH3F. So it also increases up a group. Okay. I think it decreases down a group. Anything is possible. Now, method of preparation. Now we are going to prepare. We are going to prepare haloalkanes and haloarenes. So, preparation. So there are different methods for preparation. First, we will be learning preparations from alcohols. In that, there are different methods to prepare from alcohol itself. Like we can prepare using SOCl2, we can prepare using HX. So there are different methods. First, we'll be learning a reaction with hydrogen fluoride or HX, like HCl, example HF, HCl, HBr, etc. HBr, HI, etc. So the reaction is like this: ROH plus HX. You know what happens? This X will go to this R and OH. It's like this an interchanging reaction happening here. We'll get RX plus HOH means what? It's really HOH means water, H2O. So this is the reaction. Now this reaction is having a mechanism, very important. Really this reaction can have two mechanisms if it needs. If it needs, it can have what? Two mechanisms. Still, if this reaction, no need of the mechanism, I think. I'll just tell you one thing. This reaction is very special reaction. Really, this reaction is very special. Why it is special? Because that there are primary alcohols, secondary alcohols and tertiary alcohol. Tertiary alcohol. In this, for the reaction with HX, primary alcohol undergo this reaction with SN2 mechanism. Okay, SN2 mechanism. So now I'm going to write the mechanism for this reaction, for primary alcohols reaction. It is like that. We are having a primary alcohol with us. Oxygen is having what? Lone pair. Now it happens in an acidic medium because it's a HX, H plus, X minus. H is very electropositive, X is very electronegative. Hence H we'll get it as H plus in the medium. So we'll get here R. This electron pair will be donated to this H. So it becomes RO plus H twice. Now what happens? We got this thing. Now X minus is very intelligent at this very unstable state, because look, oxygen is electronegativity second rank holder, or the second most electronegative element. It's having a positive charge on it. It is very sad. So what happened? Halogen is very intelligent. It will tell that I have electron with me, come with me. It will go and attack here in the oxygen. What happens here is like, one second. Sorry. X minus will come to R. So oxygen is like, anyway, a person with a negative charge, electron rich person came to the R group or alkyl group. Then why should I stand here? So what happens that we are having a transition state. Transition state means a state of change. Here X, the halogen atom is coming near to the alkyl group, and the OH2 plus, this atom, this thing is going away from it. So this is a transition state. You know that in SN2 reaction, we learn SN2 reaction. You have learned SN2 reaction in last year. You have not learned. No, you have not learned. Sorry. In SN2 reaction, there exists a transition state. In this transition state, the transfer happens. Okay, I hope you understood. No, you learned SN2 reaction last year. For this, or if you have not learned SN2 reaction, I'll make a special video for SN2 reaction alone. But I can't include SN2 reaction in this because this already I'm showing it here. Now once again in this chapter SN2 reaction is being dealt. But in NCERT they have not given nothing like this, this mechanisms and all for the reaction with alcohol. But I am giving it because it's important for what entrance coaching, entrance examinations. So we are having a transition state. After this transition, what happened? It becomes Rx, and this thing will go and become what? H2O. So this we'll get at last. This is only for primary alcohol. Now for secondary and tertiary alcohol, secondary alcohol and tertiary alcohol, the method is SN1 reaction. SN1. So what is the speciality of SN1 reaction? Now this reaction is having a carbocation intermediate. It doesn't have a transition state. It already have an intermediate. Intermediate means a compound which can be separated during a transition state is just a state that we hypothetically make. But intermediate is something that exists in the in the reactions that we can separate out from the reaction. And hence this is having a carbocation reaction. There are possibility for rearrangement reaction. Okay. Sorry. Mend reaction. Okay. Yes. So the mechanism is like this. We have ROH, we have H plus. The first step is same. We get ROH twice plus. Now this ROH twice plus will escape simply. Step 1, which will escape simply. This step 1 is called the rate determining step. And we get R plus plus H2. Now rate determining step means this step is the step which determines the rate constant of the reaction, and we have learned the same in the chemical kinetics chapter. Now R plus plus X minus will combine in step 2, and this is what? Fast step, and we get Rx. Here this R plus carbocation. You just take this R. You just take the compound ROH to be a secondary alcohol. So it will be like this: CH3, CH2, CHOH, CH3. This was our compound. Now if this undergo reaction with the HX, and what happens? We get first a carbocation. Carbocation will be formed from where the alcohol is left, right? Where alcohol left. So we'll get a carbocation here. In reaction mechanism chapter, first year reaction mechanism chapter, we learned that primary carbocation is very less stable. Secondary carbocation, tertiary carbocation order. This is the order for carbocation. So tertiary carbocation is more stable. So here you know that this is a secondary carbocation. This is a secondary carbocation. It's stable but not as stable as tertiary. So what happens here is that, look, here we can see a methyl group. Here we can see a quaternary carbon with 4 carbons attached to it. So this plus charge is like, I want to go to this carbon. If one CH3 group leave from here, this carbon becomes what? Tertiary carbon, right? So what this plus charge will do, that this plus charge will use its power to remove the CH3 group, and the CH3 group will be like this, and this plus will go to this. So what happens here is that C plus CH3 CH2 minus CH3, and this one CH3 plus that was removed from here, still here, the plus charge. Now this thing will see this minus charge and come and join here. So here a rearrangement, methyl shift, a shift of methyl group happened here. So we'll get, becomes like this, right? So here we have plus charge. Now what happens? Now that X minus will come and join, and the compound will be CH2 CH3 CH3. Okay, so this is the basics of this reaction. I explained this reaction so detailed that now everyone can answer what is an SN1 reaction. So I have explained this preparation from alcohol very detailed, very detailed, that the time is exceeding so much to make you understand this. That's my need. That's the reason. Okay. Yes. Now I explained these two reactions. Now we will do one question. We did already the same question once. Now what we will do? Okay, 1 second. Yes. Now we are going to learn a special condition of the same reaction called as Groove's process. So, first of all, if we are using ROH and H, we told HX here, HX. Here H, we told here it is HX, right? HX. But here we are going to use HX. Here we are going to change the X and put RCl. Okay. So this is called Groove's process. Here what's the thing? We are using RCl. Sorry, not RCl. Sorry, it's HCl. Okay. HCl, and we used a special reagent here which we didn't tell, that is ZnCl2. You understand that this HCl should be concentrated, very important. Now this concentrated HCl plus this anhydrous means without water, okay, anhydrous ZnCl2 is called as Lucas reagent. Now we use this Lucas reagent for preparation of haloalkane, okay, but mainly we use this Lucas reagent for what? Identification of alcohols. Identification of alcohols. Okay. So to identify alcohol, we use this. Normally we use this to identify a alcohol. Okay, perfect. Now, how to identify alcohol using this Lucas reagent? You understand that first we are using a tertiary alcohol. with this Lucas reagent. So a tertiary alcohol, R dash, R double dash, R triple dash, and the OH. A tertiary alcohol plus HCl plus I'll just write Lucas reagent. You know what is Lucas reagent, right? If I'm writing everything, it's Lucas reagent. Lucas reagent. I will get RCl. I'll get RCl for sure. RCl for sure plus H2. Here you can note something is that if we are using a tertiary alcohol here with Lucas reagent, RCl is formed very fastly. RCl is formed. So when this haloalkane is formed, a turbidity appears. Turbidity means what? You are having a glass here. You're having a glass here, okay, and you put Lucas reagent and water, ROH here. Turbidity means this thing will become what? Like a curd. It will become turbid. It will become like turbid means it will it changes its liquid characteristics and retain to solid characteristics like that. Okay, it becomes turbid. It becomes like the consistency of the curd and all we get, right? Curd, right? Curd. Okay, that's called turbidity. Now, if we use a tertiary alcohol, we get turbidity immediately. Whenever we put this tertiary alcohol to Lucas reagent, we get the turbidity. We get turbidity immediately. Now, secondary alcohol, if we are using, we get turbidity, but not that fast. We get turbidity within 5 minutes. Turbidity within 5 minutes. 5 minutes we'll get. If we are using primary alcohol with Lucas reagent, what happens? Means turbidity is like a precipitate, okay? It's like a white, it's like kind of precipitate. Look, curd is like a precipitate. When you can note, when you keep a curd for a long time outside, it will I don't know what to tell it in English. It will split. Curd will split. It will become with a piria. In my language, it's told like that. We'll get something like that. That's called turbidity. Okay. Now, if primary alcohol is no turbidity, no turbidity. Here, what we can understand, and by that's why I am telling that we use this method not for the preparation of haloalkane, but for the identification of which alcohol, primary, secondary or tertiary. If we get turbidity very fast, it's tertiary. In 5 minutes we get it's secondary. No turbidity means it's primary. We can identify. That's the order. So order of reactivity is a tertiary, secondary, primary. Now depends on the nothing. This is enough. This thing is called Grove's process. Okay, this thing is called Grove's process. Over. So by now it comes to an end. Grove's process and all come to an end. Now I am giving some other reactions with alcohol itself, not HX and alcohol, but some other reactions. You can note. We don't have specific name, but we can just note ROH plus NaBr plus H2SO4 give RBr plus H2O plus H2Na2SO4 NaHSO4. Okay. This is one reaction you can note down. You can just see this reaction and go. You need to learn so much. This is never asked before, but you can just go through the reaction. The above one with alcohol is most important. This is also another reaction with Ki. This is also just learn. Just. For your sake, you can learn. Okay. That's over. Now we are going to learn some reactions. B. Reaction with PCl3 and PCl5. This thing is important. So if we are using ROH plus PCl3, we get RCl H3PO4. If we use ROH plus PCl5, we get RCl plus HCl plus POCl3. This thing is important. So this reaction is, you can just note down. They can ask this thing if you need. What we get as a byproduct when we use ROH and PCl5 to prepare a haloalkane? We get POCl3 as a byproduct. Now another reaction with the halogen in presence of red phosphorus. Nothing, you can just learn this reaction ROH plus red phosphorus and halogen. Halogen we use is normally Br2 and I2. We don't use Cl2. Okay, Br2 and I2. We get RCl. Not RCl, sorry, RX. This is a reaction. Okay. The next one is important. Reaction with SOCl2. The speciality of this reaction? The reaction is simple. ROH plus SOCl2. Just rearrange RCl plus SO2 plus H2O HCl. Okay. SO2 is a gas and HCl is also a gas. This is the most apt method to prepare. The reason is that as the byproducts are gases, what happened? When we prepare using this method, RCl we get in the most pure form, because after we preparing this thing, like I'm having my tumbler here and I'm having my things here. So I put ROH plus SOCl2. Now what I get is RCl here. The other two byproducts will fastly go out as gases, and hence I get pure RCl without impurities. I get it. Therefore this is the apt method, because byproducts are gases. Okay. And this method having a name, and it's called Darzen's process. So the other one is Grew's process, Darzen's process. Okay. Now the reaction with SOCl2 in ether medium, reaction with SOCl2 in PGT medium. Okay. Now this reaction with SOCl2 can happen in two different mediums. Mediums means like the aqueous medium, acid medium, basic medium, like that. So reaction of SOCl2 in ether medium. How can I How can I perform the reaction of SOCl2 in ether medium? Okay. So look, this is this is a alcohol. Now I am adding SOCl2 into it. In which medium, children? In ether. In ether medium. Okay. In ether medium. Ether. What happens is that SOCl2 being so intelligent, we get something like this. O S Cl O. Okay. We get something like this. Okay. Here first of all what happens that this H and one Cl from here go outside, and what happens is the rest of SOCl go and attach here. So we get something like this. Now what happens is this chlorine being so intelligent go and attach here, and this SO2 go outside. This thing is not that important, but still you can understand if you need. And we get Cl. And Cl. And this is the method. We got what? SOCl. We got what? RCl. So this is a Darshan's process itself, but in ether medium. And this mechanism's name is important. It is called SNI mechanism. Means nucleophilic substitution, internal returns. Internal returns means, look, all the reaction happening here is internal. Here Cl is coming here, going here, full everything happening is inside the atom. Internal compensation, internal reaction, internal returns. That way this mechanism is called SNI mechanism. And when we use ether medium, we have SNI mechanism in Darshan's process. But if you are using SOCl2 in pyridine medium, what happens? We are gonna see the same here. We have ROH plus SOCl2. The same thing happens first. HCl will go outside. Now we have OS double bond OCl. The same thing above. Now what happens is that pyridine is a base. So pyridine is a base, and it's so nice that this pyridine gives its lone pair to sulfur, and this chlorine go outside. So chlorine Cl minus leaves. So what we get? I need space to draw the same. So chlorine gas leaves. Now we have OS double bond O Cl1, but we have now nitrogen with plus charge because it gave its lone pair, and the sorry, the pyridine shape is wrong. Very sorry. Okay, yes, this thing is here. Now what happens? We have the Cl minus which left before. It will go and it will come and attack here, and this oxygen will leave, and we get RCl from the opposite orientation. Look, here we had wedge orientation, now we have dash orientation. But for the above mechanism, OH was in wedge orientation, and RCL also had wedge orientation. But here OH had wedge orientation when we see the pyridine medium, but this had what? Dash orientation, or the opposite orientation. That's a inversed product. We get inversed product. That's a speciality of this reaction. Okay, and plus we have our, what happens is O is leaving, so SO2 is leaving, and N also leave. Otherwise we don't get the catalyst back or the medium back. We should get the medium back. Otherwise the reaction is called very unperfect or imperfect. We get pyridine back. So this is the reaction, and this is called what mechanism? SN2 mechanism. It's a transition state. Look, something is going here, coming from here, something is going out here. This is called what? Transition state. So this is a SN2 reaction. Above one was an SNI, internal return. Now reaction from reaction from alcohols, or preparation from alcohols completed. 45 minutes for this class means it's so detailed. It is so detailed, haloalkane haloarene. And if you people like watching my channel, I'll upload the next part, that is the rest preparation, the rest reactions, etc. from the chapter haloalkanes and haloarenes. From alcohols, I give many extra methods. This Darshan's process, this SNA mechanism, SN2 mechanism, SN1 mechanism, Grew's process and all else, not given in your NCERT textbook. I gave this specially for entrance batch, and I'm giving this for all the people who can afford entrance coaching or who didn't get an entrance coaching. You can prefer this video and crack JE if you try, or CET examinations. Okay, understand? It's a very good opportunity for you to learn. So learn, and I hope you enjoy my classes. It's my first attempt. Anyway, this is my classes about. Thank you and have a nice day.